Welcome to 3.2. We're going to be looking at equality, solving equations, and the first thing we're going to talk about is the addition and subtraction properties of equality. So that's what we're going to spend 3.2 focused on. All right, so let's talk about what a solution is. A solution for an equation is a number that, when used in place of the variable, makes the equation a true statement. So it's the value of the variable that makes the equation a true statement. That's what a solution is. When you plug it in, it makes a true statement. So we could look at something even more basic than the example here, and we could say something like this: x plus 2 equals 5. What number here, when you add 2 to it, gets you 5? 3 is that number. So what we suggest is that 3 is a solution to the equation, because if I take this 3 and I plug it in for my variable, it makes a true statement. So the example here, this example 1, is a little more complicated, but it's the same idea. It says, is a equals negative 2 a solution to the equation 7a plus 4 equals 3a minus 2? And the way to find out is to take that value and to substitute it in for any variables that we have that correspond to it. So in this case, we have 2 different a's in 2 different locations in the equation. Each one has to get replaced at the same time by the proposed solution. So we'll see. Does it work out to be a true statement? So 7a plus 4 equals 3a minus 2. So is negative 2 a solution? Let's find out. We'll plug it in. And we'll see, once we simplify each side, if we get the same thing on each side. And if we get the same thing on each side, then it's a true statement. And if we don't get the same thing, then it's not. So 7 times 2, negative 2 rather, is negative 14. 3 times negative 2 is negative 6. Negative 14 and 4 is negative 10. And negative 6 and negative 2 is negative 8. So is negative 10 the same as negative 8? Nope, they're not the same numbers. So this is a false statement. So false. So negative 2 is not a solution to the equation, because when you replace the variable with the solution or proposed solution, it doesn't make a true statement. Okay, so armed with that knowledge, let's talk about the addition property of equality. So the addition property of equality says, this is an important concept here, it says if A equals B, if 2 things are equal, if 2 things are the same, then if you were to add something to one of those things, you would have to add the same thing to the other side in order for the statement to still be true. If it started out that A equals B, and you add C to A, well, you better add C to B in order to keep things equal and fair and the same value on each side. So In words here, they say adding the same quantity to both sides of an equation never changes the solution to the equation. Think about something, really basic, like 3 equals 3. Well, of course it does. Well, what happens if I take 3 and I add 2? Well, on the other side, is 3 plus 2 equal to 3? No, it's equal to 3 plus 2. The only difference is, instead of starting with 3 equals 3, we'll often start with something like x equals 3. But if x equals 3, then if I wanted to add 2 to my x, I would also have to add 2 to my 3 to keep this a true statement. And so then I could simplify, of course, a little bit here. And then I could solve this. So in this case, let's go look at this example. In this example, what we've started with is x minus 5 equals 12. What number, when you take away 5, gives you 12? You may already be thinking what some possible solutions could be. You may already know exactly what it is. Here is one way we can find it using the addition property of equality. It says if one side of an equation equals another side of an equation, what I can do is I can add something to one side as long as I do it to the other side as well. So as long as I add it to both sides. In this case, if I were to add 5 to this minus 5, well, minus 5 plus 5 makes 0. And that would be very convenient for me because then I would just have my variable on the left and I wouldn't have any other numbers messing with it. And so then I could see clearly x equals some value, and then I would know what the solution could be. So what I'll do is I'll add 5 to this side, and that means I have to add 5 to the other side as well to keep them balanced. So I added 5 here, and I added 5 there. Otherwise, the original equation stayed the same. Now my goal is to simplify. Minus 5 plus 5, that's 0. So I actually don't need to write anything at all because minus 5 plus 5 makes 0. 12 plus 5 makes 17. So now I have a proposed solution. I think that x in this original equation equals 17. How can I check it? How can I know that I'm right? I can take that value and I can plug it in for my variable and I can see if it makes a true statement. So my equation is x minus 5 equals 12. I think x is 17, so let me plug it in. 17 minus 5 equals 12. 17 minus 5 is 12. 12. So sure enough, 12 equals 12. I got a true statement. This checks out. So what that means is that my proposed solution is in fact correct. I checked my solution and I know I'm right. So that's the addition property of equality. We can add something to one side as long as we add it to the other side as well. We have to add everything we do to both sides. Now that also goes for subtraction. The subtraction property of equality says the same thing. It says if two things are equal and you take away something from one of those things, you have to take the same thing away from the other side if you want them to remain equal. So subtracting the same quantity from both sides of an equation will not change the solution set, right? The value of the solution will not change if you add or subtract the same thing to both sides of an equation. So, what should you add and subtract? That's where the strategy and the practice comes in. So let's take a look at this next example. It says solve x plus 4 equals -2. Solve for x, right? X is my unknown, so I'm almost always solving for my unknown. In this case, I wouldn't want to add something in order to get my variable alone. I would want to subtract something. So in this case, the opposite of +4 is -4. So if I were to subtract 4 on the left, then my variable, my x, would be all by itself. And then I could see what it was really worth. And as long as I do that to the other side, then it's a legal move. So let's have a look. X plus 4. I'll go ahead and take away 4 on the left. And I'll take away 4 on the right. So +4 minus 4 is 0. So I just have x on the left. -2 minus 4 is going further in the negative direction, so -6. So this is my solution, or at least my proposed solution. How can I check it? I can take it and I can plug it in for my variable and see if I get a true statement. Do I have to do this every single problem? No, not necessarily. But I do have to practice it in this chapter because it's a key skill in solving equations and confirming that your solution is correct and knowing that you're right. It's the only way to know that you're right, really, is to plug it in and see if it works. And we want to be able to do it, especially on a test or whenever we're in doubt. And so that's why we're going to practice it now. So let's take this x plus 4 equals -2, and we'll plug -6 in for my variable, and we'll see if it's true. -6 plus 4 is -2. So sure enough, it checks out. And then that means my solution is a good solution. It is a true solution to the equation. All right. This problem is going to ask us to solve for y, and we're going to have to do some work in order to make that happen. As you can see, there are two different terms that have y in them. One of them is inside parentheses, so we're going to have to distribute to get rid of those parentheses so that we can combine like terms. Then we're going to have to use the addition and subtraction properties of equality in order to get the y on one side by itself. Now, in the past, we've been looking at the variable on the left side, but there's no rule that says the variable has to be on the left side. It is convenient to read the answer as x equals some number or y equals some number, but it is not a rule that we have to get the variable on the left. It's just often what we do. We can just as easily, and sometimes it is easier and makes more sense, to isolate the variable on the right-hand side. And we end up with all our numbers simplified on the left-hand side, and that's just as good. So let's have a look at this problem here. 10 equals -3y plus 2 times the quantity 5 plus 2y. So the very first thing I'm going to do in order to get my y terms together is I'm going to have to distribute. So this is just going to come down. 2 times 5 is 10, and 2 times 2y is 4y. Now that I've distributed through the parentheses and I've doubled both my terms inside parentheses, now I can combine like terms. I see I have -3y plus 4y. Well, a +4 minus 3 That's 1. That's a single y. So now I have 10 equals y plus 10. Right? Because if I look at this over here, 4y minus 3y, if I have 4 potato chips and I eat 3 potato chips, I'm left with 1 potato chip. And that's represented down here. Now, I don't have a single y by itself. I have y plus 10 on the right. And I want to get y by itself isolated so that I know what it's worth. I know what its value is. So to do that, in this case, I could subtract. I could subtract 10 from both sides, right? Right here, I could say, well, 10 minus 10 equals y plus 10 minus 10. So I took the previous line and I simply subtracted 10 on both sides. Let's see how this cleans up. 10 minus 10 is 0 equals y. 10 minus 10 is 0. So we think that y equals 0, which may seem like a strange solution, right? It's not a number like 5 or -3. It's 0. But 0 can just as easily be a solution as any other value. And we can check it and we can see if it is in fact the solution by taking it and plugging it back into our original equation. So let's do that. Let's say 10 equals -3y plus 2 times the quantity 5 plus 2y. So what I'll do is I'll go in and I'll replace everything that is a y variable with the value 0. And in this case, because there are coefficients, there are values multiplying in front of my variable, I do need parentheses to show that that multiplication is happening once I turn the y, the variable, into a number, a constant. So let's have a look here. So 10 equals -3. Instead of times y, I'm going to say it's times 0. That's my proposed solution. Plus 2 times 5 plus 2 times 0. And so I need the original parentheses for the 5 plus 2 times y, and I need the parentheses around what I'm substituting in for my y, which is my proposed solution, 0. So now I'm going to keep cleaning this up as much as I can. Nothing to do on the left-hand side. -3 times 0 is 0, okay? Plus 2 times, I should do what's inside parentheses first, so let me do that first. 2 times 0, so that's 0. Okay, so that's really just 10 equals, I don't need this 0, so it's 2 times 5 plus 0, so just 5. 10 equals 2 times 5 is 10. Oh, sure enough, that checks out. So that means my proposed solution of 0 is in fact a true solution to the equation. So let's talk about some of the key points and wrap up what we did in this section. So what is a solution to an equation? A solution to an equation, and I'll give you a second. You're welcome to pause it and answer in your own words. A solution to an equation is a value that, when substituted for the variable in the original equation, makes the statement true. So, value of a variable that makes the statement aka the equation, the original equation, true. So that's what a solution is for us. That's what a solution to an equation is. All right, B. True or false? According to the addition property of equality, Adding the same value to both sides of an equation will never change the solution to the equation. True. The addition property says you can add anything you want as long as you do it to both sides of an equation. All right, let's have a look at C. Show that x equals 5 is a solution to the equation 3x plus 2 equals 17 without solving the equation. Okay, they want us to show that it's a solution without solving the equation. So what could we do? We could check it. That's right. So we could say, well, 3x plus 2 equals 17. Well, that's 3 instead of x. We think the solution is 5. So let's plug it in and test it out. So 3 times 5 is 15. And 15 plus 2 is 17. So sure enough, 17 equals 17. It checks out. So we showed that it's a true solution. It is a solution without having to solve the equation. All right, D. True or false? The equations below have the same solution. Equation 1 has a solution. 7x plus 5 equals 19. We don't necessarily know what the solution is, but it has a solution. Look at the line below. What's different about them? The only thing that's different is that 3 is being subtracted from both sides. Well, as long as it's being subtracted from both sides, it doesn't change the solution, the value of the solution. So the equations have the same solution? True. All right? So if you have questions about that or anything else in this section, please reach out to me, make an appointment, and I'll be happy to help. See you in the next section.